is a lot of fun. Me and Mr. Bones really like this thing. So, welcome to week 8. And this week we're going to be discussing what are the types of energy. So, we've talked in the past about the different types of matter and the states of matter, where there's solid, liquid, gas, and plasma. So those are our 4 states of matter. But energy, just like matter, it's all around us as well. And it's moving around us and transferring energy from one state to another all around us all the time. And we've been able to figure out that there's 9 types of energy that we've been able to classify. So the 9 types of energy that we've been able to classify are thermal energy, like from Spanish, it's mucho hace frío, which is cold, and hace calor, which is very hot. Those are thermal energies. Then there's chemical, which we see that chemical reaction all the time. Well, we don't really see it, but it happens to us every time we eat a meal, our tummies. Lots of chemical reaction going on there, chewing up that food, bringing the nutrients out to feed us, and sending the waste all the way through it. Then we have electrical energy, which, the sky opens up, we get lightning all the time. That's electrical energy, but also every device we use runs off of electricity. That's electrical energy. We've harnessed it, and it's changed everything about our world. Then we hit sound energy. If any of you has a sibling or a parent, I'm sure you've had to listen to their sound energy one time or another. But also instruments and music, all sound energy. It transfers so much between us. It's how we communicate. That's sound energy. We have radiant, also known as light energy, and that's energy like when the sun gives off, when the photons go out. They just go out in 360 degrees all the way around. They just radiate out from the center in all directions. That radiates out like that. We have nuclear. Biggest nuclear reactor that we know near us is the sun, but we also have nuclear reactors, I believe, a little bit north of us, which also provides us, or south of us, which also provides us with electrical energy. So we've been able to harness certain types of elements that have radioactive decay, if you remember that from the weak force of the 4 fundamental forces, and we've been able to harness that energy and turn it into electricity, which we also use. Then there's mechanical energy. Swing, every time you're on a swing, you're using some mechanical energy. Mechanical energy is also the foundation of what we've sort of built our societies on, because it comes and we've used it into all of our simple machines. The very things that have taken us from walking around and figured out the Stone Age, where we start to be able to develop tools. That's all going to be simple machines, which is coming up in the future. And then we have elastic. Elastic's an interesting one, because if you have a rubber band, that's elastic energy. When it's at rest, it's sitting there. When you stretch it out, that energy is forcing and squeezing things into it. The other thing that we have that has elastic energy, which helps us and saves us all the time, our skin. When you fall down and you bump yourself, or you skin your arm, you get a little skin on your skin flexes all around you all the time. It's full of elastic energy. It's waiting for something to hit it so that it can deform just a little bit and then come right back and reshape itself to be what it was before. So that helps you a lot. So you get a little scrape, it could have been a lot worse had your skin not been very elastic. And the last force, it's the one that keeps us on the planet, it's gravity. It's that thing where a big mass and we're little masses and we're attracting to each other, and it keeps us here on the ground. So no matter what I do, I stay right here. So let's see if we can do a little experiment with a few of these that you can also do at home. Here I have a table full of energy. All these are different types of energy. The easiest one to notice is my little plasma orb over here, which is showing me electricity. Just electricity arcing, just like lightning. Just those electrons jumping from the center, trying to get all over my finger. Then we have some sound energy. Chimey bells. If you can hear that, that's energy transmitting over to you. Then there's elastic, as I said, rubber bands sitting here. It's waiting. Now it's pulling on my fingers. That's a lot of energy trying to pull my hands back together. Oh, got thermal. Do I have thermal? Ah, there it is. So thermal energy, I can feel the heat from the flame on my hand. If you have a heater at home, especially if it's going to get colder, you'll be able to feel that thermal energy keeping your home warm. Then we have an item that I know you all love playing with right here. And this is our mechanical energy. As it goes from one side, it transfers its energy through the balls and comes out the other side and does that. Super cool. And makes a long clacking noise for a very long period of time. So I'm gonna mute that out. And then we have radiant energy, where if you've ever walked into a dark room, ta-da, it's radiating that light out all over so that the entire room can be illuminated. Let's see, what else do we have here? Oh, we have this. This is going to be our chemical reaction. So I got a different powder than I normally do. It's cool and it's green. And I got this other interesting chemical here. And if I mix them together, hopefully we'll have a chemical reaction. As the bonds of one interact with the bonds of the other, breaking the atoms apart, releasing gas, releasing different compounds. And it's a lemony explosion. All right, so we just looked at some cool experiments, which you can do at home, and you can also look around to see if you can find different sources of these energies just around your home and in your daily life whenever you're out on your drive or with your parents for a nice hike. Further, we've just divided energy into two different categories just to even go deeper into what's out there. We've categorized them as renewable, which means they're easily replaceable. If we use that source today, we go to bed, we wake up tomorrow, that source is probably still going to be there. And then non-renewable, which means non-replaceable. These are sources that exist on the planet and have helped us as a culture greatly by allowing us to build huge buildings and to move across the frontier and to just see everything, including driving in your car. So the non-renewable ones are stuff like gasoline, which powers your car. Also coal and even nuclear. We mine these like radiums out of the ground, and they throw off this radiation, which is the weak nuclear force, and we have figured out a way to harness that in order to give us power and electricity, which powers a lot of cities around the world, actually. So those are non-replaceable, and unfortunately, they will run out at some point. And in order for us to go and live on another planet, or progress as a civilization, or live on a space station, I want to live on a space station, these sources of energy won't be around for us to use, so we need to look for renewable ones that have been there forever. And we have a lot of scientists working on this and a lot of engineers that are really working hard to figure out how to harness these sources. There's sources like the sun. The sun is there all the time, throwing tons of energy at us, like just tons and tons of it at us, and we're just now figuring out how to really harness this like free amount of energy that's been given to us. There's also tidal energy. So you have the Earth, you have the moon. As the moon travels around, the gravity of the moon causes the water to lift up, creating these tides across our planet. Is the moon going anywhere? I hope not. It seems pretty cool. Seems like it likes rolling around us and saying hi every night. It's totally awesome. We can harness that energy that it's giving off. Also, plants. We can have farms which have all these plants, and we have all this extra biomass that we can convert over into different types of fuels that we can use. So there's tons of things that we can look at that are already out there in the world that we just haven't really paid attention to, because honestly, digging a hole in the ground and pulling out coal and putting a hole in the ground and pulling out oil just has been easier up until now. But in order for us to go further in the future, we need to start thinking bigger. We need to start seeing what's available and realizing there is a plethora of sources out there if only we put our minds to it and our science to it. So that'll end science. Bye.